Okay, let's continue this problem as it was cut off from, I think, step C or step D. Okay, let me just start from step D again. Then. So I want to correct something. So in here it's a queue, so it's first come, first in, first out. So that's why like it's an order. So like if it's R T X like step C, then you have to goes to R first, and then you reach from R to the next vertex, which is V, and then you like how it shows in step D, then the R become black and then the V become gray. Then from there, and then you just write V after X, and then it'll be as 2, mark as 2 too. And then in step E, it goes from start from X. Now then you're actually T, yeah, because from step D it's T is the first one, so you from T reach to U, and then you mark the T will be black again because it's finished, and then from T goes to U, you become gray, and then you goes to the next one in the queue, which is X. So in step F, this X becomes black because it's finished process, and then your X will be reaches to Y, and then Y will be the next one in the queue, which is on the right, and then it will be marked as 3, same as the U, and then you're done with it, everyone, but you have to mark the color, so that is why the V becomes black in the step G, and then H in step H, the U becomes black, and then in step I, everything becomes black because you have to make sure you mark all the vertices black once you finish, even though you already finished visiting it, but they're still in the queue. So you have to mark it black in order to cross it from the queue, because it's a queue, so it has to be in and it has to be out from queue. So that's how this problem works. Hopefully you understand after my explanation, and also you have a better understanding how the breadth search works, as particular to the question. If you have more question, you can like email me so I can help you, or yeah, we can set up like a section to talk about it. And then here there's a practice problem. In here you can like screenshot it, or if you want it, I can send you like a copy of it too. This is like similar problem, but this one is with directed graph, so you can use this one to practice the breadth first search. And if you want to answer, like you can do it and then like email me. I will tell you if you did it correctly, or I can send you the answer. If you do not understand something, I can also explain it to you. And now I will talk about the depth first search. So this is an algorithm for traversing or searching tree similar to breadth first search. Yeah, like or a graph data structure. So it's similar for breadth first search, but still a little bit different because it started from the root node and then explore as far as possible along each branch before backtracking. So it explored the graph from every vertex, and there's no source vertex given. So it's different from breadth first search. So you can start from any vertex, and then it constructs a forest of trees and recording 2 timestamps on each vertex. So it'll be the first one will be the discover time, which you can denote as v.d, and then also another one will be the finish time. You can denote as v.f. So it's different because this one also uses color, like white, gray, and black. White being the one that's not being visited yet, and then gray is the one being visited but not finished processed yet, and black will be the one that's already been processed. So let's talk about like the pseudocode. So in here you see there's a pseudocode for this depth first search DFS. Then it has 2 different ones. The first one on the left right here, it's the one you just the normal one that you goes to for each vertex, and then it start from wide, and then the time be 0, and then it goes to each one, and then it also use another pseudocode which is called DFS visit. So that one's in like recording like the time. So you have to like add the time and also mark a different color once you visit, and then also there's a start time and then a finish time. So you will see how it works when I go to example later in the video. And here is the example. By the way, the Sudoku might look different than the textbook, but I think this one is maybe better than the one in textbook. I just personally think that this one's better. Well, but it also depends on different people. You can prefer either one. I mean, they're all correct Sudoku, but the one I just mentioned, you will use it in 311 more. So if you understand better, then you have a better time in 311. So here is an example for it. This one, it's like it has it has arrow, so it's a directed graph, and it has 6 vertices, and all from like can reach from different vertices. So it starts from U, the one on the most left top, and then it be marked as 1 slash. So the one on the right side, left side of the slash will be the start time. The right side of the slash will be the finish time. So which is the D, the VDA D and the VDA F. Yeah, D is the discover time, will be start time. And finish time will be the F. Yeah. So that's why it will be marked 1 slash, and then it's gray. And then for step B, you can see that because has an arrow pointed from U to V, you can also be pointed to V. So that's why then it goes to V and then be marked in the 2. And make sure you also have like a stack on the side, because it is a stack like search, like tree, so it will be easier for you later when you backtrack the finish time. So then from V you can go to the Y, as you say shows in step C, and then from Y in step D you can go to X, so before X will be marked with 4 and slash, and then from X you cannot go to any other node that's white, because it's all been gray. Like if you from X you goes to Y, Y is already gray, so which means you have to backtrack now. And then so for finish time for X, for the X will be 5. So that's why on step F there's a 5 being marked in the X, so it'll be 4 slash 5. 4 will be the discovery time, and the 5 will be the finish time. And then being colored black now because it's finished process. And then you go back in your stack. Next one will be the Y, which is shows in the G. So Y will be finish time will be 6. So it has 3 and 6 and be marked black now. And then you go back to Y, I mean V, not Y, V, which V becomes black in step H. Then mark 7, and then in step I you will in step J you go back to U, and you has a start time as 1 and the finish time will be the 8. And then when you are done, do this for this, and then you have to start from the new node, as all this for this nodes it's being finished. So you start from W, which is shows in step K, and you mark it as 9 because that's the next available number. And then from W you goes to Z, because that's the only one that's not been processed, that's white, and then which is shows in step M, and then it has a start time as or discover time as 10, and then in step O you can see that the Z being marked at 11 as this finish time because it has a self loop, and then being color black, and you go backtrack, you will go backtrack, and in step P you can see that backtrack to W, and you being marked 12, and then it also being color black as it finished process, and then you can see that's how it works. And also maybe you notice that there being like some letter labeled in the for different vertices, no, not vertices, the edges, because there's different type of edges. There's a forward edge, back edge, and also cross edge. Um, forward edge is kind of, I mean, for this kind of different edge, there's also tree edge. This is kind of complicated to say for now, so I will not go into too much detail about this as for right now. But if you want to know more about it, you can email me. I can talk to you about it and explain to you how these edges work. And it will be benefit to know these edges before 311. But don't worry about it if you don't understand this, because you will learn how to identify this kind of edges in 311. So yeah, hope you understand this question. And here it is. This is a easier example, and that you can like work on it. That's a practice. So you start with this one, as it says like D in this node and F. So you start from this node, and then you can go to use depth first search to mark all those vertices, and make sure to practice this question, and then email me if you have any questions. I'll be happy to answer them. And as I finish going over the breadth first search and the depth first search, let me like compare both of them, as they're kind of similar, but they also have some difference. So the breadth first search uses a queue, and the depth first search will just use like a stack like manner, so they are different. And the stack is like a recursion stack. So, and best first search is a FIFO, first in first out queue. It explores nodes at each distance before going to the next distance. You have like number 1 and then 2 and 3, as you remember from the last video or the previous like earlier in the video what I talk about. And then depth first search implement the stack, so it use like LIFO, last in first out. So whatever that's goes in the stack last, when you backtracking, you will be crossed out first. That's why like you have like discover time and the finish time, so they're different, and you will be easier if you use stack to track them. And so explore the more distant neighbor of the node before continuing the nodes at the same distance. So it goes deep. And another major difference in this both algorithms are as presented here, that is that the depth first search DFS will search from every vertex until all edges are explored. And while the BFS best first search only searches from a designated start vertex. Like I don't know if you remember, the breadth first search, we start from like S, and then we goes to all the way to other vertices, and also when you finish, not all the edges is being marked, but like for depth first search, we visit all the vertices, and also all the edges is being visited too. So yeah, that's the difference. Hope you have a better idea about this, and have a nice day.